Hi, my name is Jure Hitztaler.
And I'm Rok Rudolf.
We would like to introduce you to our project, which began a couple of months ago, and it's about creating a new type of wood filament for 3D printing.
As we began our ways in the 3D printing world, we stumbled upon a fundamental problem with wood filaments. They were not sufficient enough for the needs that we needed them to be.
Thus, we started our own little experiment in which we tried to create our own wood type filament, which would be recyclable, biodegradable, and most of all, cost efficient. That means cheaper than everything else on the market.
A lot of wood is being discarded each year due to illness of the trees and is usable only as firewood. We are working with professional woodcutters who handpick out the trees which wood can no longer be processed in the wood industry. The trees are then digitally registered with their coordinates and later cut down. The wood goes from the field through the drying process and finally to the laboratory.
We began by choosing the right wood type that can be used in 3D printing process and make it interesting enough for everyone to use.
The first wood tested was from a spruce tree, but we are also testing out different types of wood. In each type we are going to test its color changes depending on the temperature. So the user that is going to use our filament will be able to choose the color that he would like to when printing, from a lighter shade to a darker shade. What I have here in my hands is the first successfully extruded 3D printing filament from our original mixture. It is environmentally friendly because it's 100% biodegradable. That means if you don't like it, you can just throw it out. Or rather, you can recycle it and reuse it. We have successfully extruded around 20 meters of our original mixture filament and have already tried it in our 3D printer. It was a great success. We had no issues printing whatever we wished. The integrity of the printed items were strong and durable.
We set our goals to create a filament that would have a high percentage of wood fibers in it. So we had to find a substance that would be able to bind the wood together and still be completely biodegradable, and enable the filament to be melted at 3D printing temperatures. That's between 170 and 200 degrees Celsius. But just that was not enough. We wished that our filament would remain strong and durable after printing. So to achieve all these goals, we looked closely at biopolymers. But the most used biopolymer, PLA, polylactic acid, was not good enough for this. So we created our own mixture of polymers and combined with the wood fibers, the end product was what we wanted.
At this moment, we would like to thank our future benefactors for their contributions. Give wood a second chance. And remember, H&R needs you! Yeah!